Hello, in this video I'm going to derive the expression for the horizontal range of a projectile motion. We know that in a projectile motion, the horizontal and vertical motion can be analyzed separately. The vertical motion is of course constant acceleration motion, and the horizontal motion is constant speed motion. So to calculate the horizontal range, all I have to do is to multiply the horizontal velocity with the time of flight. The easiest way to calculate the time of flight is to calculate the time it takes for the projectile to reach the maximum point and take that number and multiply it by 2. So we apply the equation of motion v is equals to u plus at, starting from this point here and ending at this point here. Since the vertical velocity at this point is 0, we put Vy to be 0, Uy to be Uy, and of course, the acceleration is downward g. And for time, we write Tp, which represents the time for the projectile to rise to the top. So with this, we solved Tp is equals to Uy divided by g. So with this, we go back to our equation here, and we replace the time of flight with 2 times of Tp. Now we realize the horizontal range actually involves multiplying the initial horizontal and vertical velocities together. If we write ux and uy as u cosine theta and u sine theta respectively, we are able to simplify the expression into just u squared sine 2 theta divided by g. So now we have an equation which allows us to analyze how the range changes as the angle of projection increases. The graph of range against the projection angle will look like this. It's basically a sinusoidal curve. So what this tells us is the horizontal range is 0 when the projection angle is 0 degrees, and the range is also 0 when the projection angle is 90 degrees. That's when you project the projectile vertically, and that of course makes a lot of sense. We also realize that the maximum range occurs at theta is equals to 45 degrees. Because when theta is 45 degrees, 2 theta will be 90 degrees, and sine 90 degrees will be 1. And that's the maximum possible value for any sinusoidal function, which means the maximum range cannot go above u squared divided by g, and that happens when theta is 45 degrees. We also notice that this function is symmetrical about 45 degrees, or rather is a mirror image of each other about 45 degrees. This will explain why the projectile motion has the same horizontal range when you project it at 30 degrees and 60 degrees. The projectile also has the same horizontal range if you project them at 15 degrees and 75 degrees. That's all. Ta-ta!